In this episode, we're going to make the idea of blast radius feel concrete in a cloud access context, because it is one of the simplest ways to predict how bad an incident can become. In cloud environments, people often focus on keeping attackers out, but a more reliable way to stay resilient is to assume something will eventually get in and then design the environment so that one mistake cannot become a full takeover. Permission blast radius is the amount of damage an attacker can do after they obtain some valid access, whether that access comes from stolen credentials, a compromised workload, or a misused role. Scoped roles and resource segmentation are two of the strongest tools you have to shrink that radius, because they force access to stay inside smaller, clearer boundaries. When you understand these ideas, you can look at any scenario and quickly judge whether it contains incidents or amplifies them. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at segmentation in the Bare Metal Study Guide series. A good definition of blast radius in this context is the maximum set of resources, data, and actions that can be affected by a single identity or token. If a developer account is compromised and that account can administer everything, the blast radius is huge. If a compromised workload token can only read from one storage location and write to one queue, the blast radius is far smaller. Beginners sometimes think blast radius is mostly about networks, but in cloud it is often about authorization, because cloud management actions can be performed remotely once credentials exist. That is why scoping roles matters so much. It shapes what an attacker can do even when they already have a foothold. Resource segmentation matters because it gives you places to apply those scopes, allowing permissions to be tied to distinct sets of resources rather than to the entire environment. When you reduce blast radius, you are not claiming incidents will never happen, you are ensuring they cannot easily spread. To reduce permission blast radius, you first need to understand what role scoping really means beyond the phrase least privilege. Least privilege is the guiding principle, but scoping is how you implement it with precision by limiting permissions along multiple dimensions. One dimension is action scope, meaning what operations are allowed, such as reading, writing, deleting, or administering. Another dimension is resource scope, meaning which specific resources the identity can act on rather than everything of that type. A third dimension can be contextual scope, where access is allowed only under certain conditions, such as a specific environment or execution context. The combination of these scopes determines blast radius because it defines how far a token can travel and how much it can change. A role that is limited on action but unlimited on resources can still have a wide blast radius, and a role that is limited on resources but includes high-risk actions can still cause serious harm. Resource segmentation is the other half of the equation, because you cannot scope to what you have not separated. Segmentation means organizing resources into groups that represent real boundaries, such as environment boundaries, application boundaries, team boundaries, or data sensitivity boundaries. In cloud, accounts, subscriptions, and projects are one type of segmentation, but segmentation also exists within those containers through resource groups, namespaces, labels, and service-specific constructs. The practical point is that segmentation creates smaller zones where permissions can be granted precisely. If everything lives in one giant flat space, permissions naturally become broad because it is hard to target only what is needed. When segmentation is done well, you can grant a role access to one segment without granting access to others, which reduces blast radius when that role is abused. Beginners sometimes think segmentation is a paperwork task, but it directly changes the outcome of compromise scenarios. A common beginner misunderstanding is that scoping roles is mainly about preventing access to sensitive data, when it is equally about preventing control plane changes that expand future access. An attacker with a token that can modify policies, attach roles, or create new identities can turn a small initial blast radius into a large one by escalating privileges. That means role scoping should aggressively limit any permissions that change access itself, because those permissions create self-expanding incidents. A strong pattern is that most workloads and most human everyday roles cannot change access control, and only a small set of tightly monitored administrative roles can. Another strong pattern is that even administrative roles have their scope limited to a segment, such as a particular production account or a particular service boundary, rather than global reach. If you keep access-changing permissions narrow, you prevent an attacker from using your own access model as the escalator. When you see a scenario where many roles can modify permissions broadly, you should treat it as a blast radius amplifier. Another way to reduce blast radius is to design roles around specific tasks rather than broad identities like developer or engineer, because task-based roles are easier to scope and easier to audit. A task-based role might exist to read logs for a particular application, to deploy code to a specific environment, or to rotate credentials for a limited set of services. When a role has a narrow task, it becomes easier to define which resources it should touch and which actions it should perform, and that precision is what reduces blast radius. Broad roles become magnets for privilege creep because new tasks are continually added to them, and every addition expands reach. A mature environment tends to have more roles that are smaller rather than fewer roles that are huge, but it also keeps role design understandable so people can pick the right one without guesswork. The goal is not complexity for its own sake. It is controlled capability aligned to purpose. It also helps to think in terms of the difference between read blast radius and write blast radius, because these create different kinds of harm. Read access can expose sensitive data, secrets, or configurations that lead to deeper compromise, and its damage is often stealthy because reading does not break systems. Write access can change configurations, delete data, alter network exposure, or disable monitoring, and its damage can be immediate and disruptive. Some roles legitimately need read access broadly for visibility, such as monitoring roles, but even then you want to segment what they can read based on sensitivity. Write and delete permissions should generally be far more constrained, especially when they apply to shared or critical resources. In exam scenarios, an identity that can both read sensitive information and change high-impact settings has a dangerous combined blast radius, because the attacker can both learn and act. Separating read-focused roles from write-focused roles, and narrowing both by resource, is a practical way to prevent a token from being simultaneously a microscope and a hammer. Resource segmentation should be designed with attacker paths in mind, not just organizational charts, because attackers move along the paths you accidentally create. If one segment contains public-facing workloads and another segment contains sensitive data processing, the boundary between them should be strong because public-facing systems are the most likely to be attacked. Segmentation should ensure that a public-facing workload identity cannot directly access sensitive segments unless there is a clear and narrow reason. Similarly, development and production should be segmented because development systems often have more experimentation, more change, and more exposure to untrusted dependencies. Segmentation that mixes these zones creates a blast radius where a compromise in the noisiest area can spill into the most valuable area. When you design segments around trust levels and data sensitivity, you create natural scoping targets for roles. When segments are only based on convenience, roles tend to cross them and blast radius grows. A powerful pattern for reducing blast radius is to isolate high-risk capabilities into dedicated segments and dedicated identities, especially automation systems that can create or modify infrastructure. Deployment pipelines, infrastructure automation, and security tooling often need broader permissions than normal application workloads, and that makes them attractive targets. If those systems operate in their own segment with distinct identities and strict controls, a compromise elsewhere does not automatically grant access to those powerful capabilities. Conversely, if application servers share identities or permissions with automation, a compromise of the application can become a compromise of the infrastructure. Segmentation helps you keep power tools in a locked cabinet rather than leaving them in the hallway. Role scoping then ensures that even within the automation segment, each automation identity has only what it needs for its specific tasks. This prevents a single pipeline credential from becoming a universal key. Another key piece is scoping by environment lifecycle, because not all environments deserve the same access assumptions. Development environments often need flexibility, but they should not be a stepping stone to production. Testing environments often hold production-like data by mistake, which can make them more sensitive than teams realize. Production environments are the highest value targets and should have the strongest segmentation and the tightest scopes. A good design ensures that roles for development do not automatically grant production access, and that production roles require stronger controls and tighter resource scopes. This is where identity boundaries and conditional access can reinforce scoping. But even without those mechanisms, the core idea remains that environments are separate segments with separate role catalogs. If a scenario shows a single role used across all environments, that is a blast radius smell. Strong segmentation makes it easier to keep role scopes aligned to each lifecycle stage without constant special case logic. Segmentation also applies to data itself, which is often the true target of attacks, and this is where resource design becomes especially important. Sensitive data should live in segments where only a limited set of roles can reach it, and those roles should be tied to well-defined business functions. If sensitive data is scattered across many general-purpose storage locations, scoping roles becomes difficult, and teams often respond by granting broad read access to make systems work. That broad access increases blast radius because any stolen token can reach more sensitive data than intended. A better pattern is to concentrate sensitive data into dedicated storage segments and enforce that only specific processing workloads and specific support roles can access it. This also supports auditing and monitoring because access to the sensitive segment becomes a high-signal event. When sensitive resources are segmented and access is scoped tightly, attackers have fewer opportunities to stumble into valuable data by exploring broadly. A realistic approach to scoping must also account for how cloud services interact, because overbroad permissions often arise when teams are unsure which service calls an application will make. This uncertainty leads to granting access to entire services or entire resource sets just to avoid breaking deployments. The more mature approach is to start with a narrow scope, observe what is actually needed, and adjust deliberately, which treats scoping as iterative rather than perfect on day one. This is also why monitoring is part of blast radius reduction, because usage data can show which permissions are used and which are unused. Unused permissions are a direct blast radius reduction opportunity because removing them shrinks what an attacker could do with the same identity. Iterative refinement also helps prevent privilege creep because it creates a habit of justification and review rather than a habit of permanent expansion. In exam terms, organizations that never revisit permissions tend to accumulate large blast radii over time, even if they started with good intentions. It is also important to understand that segmentation without enforcement is not real segmentation, and enforcement often comes down to access control and guardrails. A segment should have clear boundaries, and those boundaries should be expressed in permissions, policies, and organizational structure that prevents accidental cross-access. If teams can casually attach roles that span segments, boundaries become porous. If central roles have unlimited reach and are used for everyday work, boundaries become irrelevant. Strong environments enforce segmentation through limited role assignment privileges, careful trust relationships, and clear governance over who can create cross-segment access. This is not about making everything difficult. It is about preventing the easiest path from being the riskiest path. When boundaries are enforced, mistakes are contained, and attackers have to work harder to move laterally. When boundaries are not enforced, a single misconfiguration can turn segmentation into a false sense of security. When you think about reducing permission blast radius in an exam scenario, a calm method is to trace what happens after compromise and ask how far the token could reach. If a workload is compromised, could its identity list resources across the organization, or is it limited to its own segment? If a human account is compromised, could it modify IAM policies globally, or is it scoped to a narrow administrative zone? If a pipeline credential is stolen, could it deploy into every environment or only into a specific staging segment? Then consider whether the attacker could expand scope, such as by assuming roles across boundaries or retrieving secrets that unlock higher privilege. This thought process reveals whether scoping and segmentation exist in a meaningful way, because real reductions in blast radius show up as blocked paths and dead ends for the attacker. If every path leads to everything, the design is wide open even if it looks organized on paper. As we close, Reducing permission blast radius with scoped roles and resource segmentation is about designing the environment so that no single identity becomes a universal key and no single compromise becomes a universal crisis. Scoped roles shrink capability by limiting actions, resources, and contexts to what is truly needed, while resource segmentation creates the boundaries that make those scopes precise and enforceable. The strongest designs avoid access-changing permissions in most roles, isolate high-risk automation, separate environments cleanly, and concentrate sensitive data into segments with narrow access. They also treat scoping as a living process, using monitoring and review to remove unused permissions and prevent privilege creep from quietly expanding reach. When you can reason about blast radius this way, you stop evaluating security by how confident a policy sounds and start evaluating it by how well it contains damage when the inevitable happens.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.